Alright guys, the moment you've all been waiting for, 8.5, using the distributive property to factor. Okay, so right now, I can't stress this enough. The next, 3 lessons that are in this textbook are of the most important, probably, maybe not, maybe I've said that before, but you are going to use factoring from now on in math. Okay, so this is going to not go away. This is something that you definitely need to be able to do. So pay close attention. All right, make sure that you ask questions. Make sure that you understand this in detail. Very, very, very important. Okay, so the first thing we do when we factor, and what is factoring essentially? That's one of the first things we need to answer is what is factoring? Factoring is simply breaking something down into its most simplest pieces. Okay, so if I have multiple pieces, finding the common thing that's in them, right? So in elementary school you found the greatest common factor between things. So that's essentially what factoring is finding the thing that's in common and breaking things down into their most simplest pieces so that we can identify special things about that equation. Like, for instance, where does the graph cross the x-axis? Like, we want to know where some of these things happen, and when things get complicated, it's not as easy to see unless we factor it. So factoring is a very, very important piece to everything that we're going to probably be doing from now on. So let's look at this. If I asked you to simplify 3x times x squared plus 2, what you would do is you would take this, what you're used to is taking this 3x and multiplying it out by the two pieces, right? So you'd get 3x to the third plus 6x. Okay. Now I ask you this question here. How could you go in reverse? How could you turn this into that? And the way that you would do that, and I encourage you to pause the video and think about it, but the way that you would do that is you would see, okay, we have two pieces here. We have this guy and we have this guy. Is there a common factor or a common simple piece that's in both of those things? And to help us see this, let's just break this down. This is actually 3 times x times x times x, and then we have plus, and then we have, essentially, if we broke that 6 down into its common, like its simplest factors, it would be 3 times 2 times x, right? So the thing that's in common with both, hopefully you can see here, is we have a 3 that's in both, and we have at least one x in both, right? So that's the thing that's in common. So what I can do is, since I have a 3 in common and an x in common in both, I can pull that out of both, and then what that leaves behind is this other piece that's here, right? So if I take a 3x out of 3x to the third, I'm left with x squared. If I take a 3x out of 6x, I'm left with plus 2, right? So when you factor something, it has to be equivalent to what you first had. So notice 3x times x squared gives me 3x to the third. 3x times 2 gives me 6x. Okay, so factoring involves taking the greatest common factor out of the polynomial. Okay, like I just showed you. We just did this on the other page, but 3 and x was in common with both of these things, so we took it out, right? And that's the factored form. So the very first thing we do when we're factoring is we always ask ourselves this question. Is there anything I can take out of all the pieces that I see here? Is there anything I can take out? So on 1A, notice the steps that I give you. Step 1, think, is there anything in common between the two terms? And the answer to that is yes, there's a 3 in both. Okay, so once I've identified that, I'm going to take that thing out. So I take the 3 out, what am I left with? I'm left with 5w minus v. Okay, and if you distribute that out, you'll get this guy. You're not changing the value, you're just changing how it looks. And then it says, check yourself. Okay, so when you check yourself, multiply it back out, make sure you actually get your original. Okay, so for 1b, let's do this one, and I'll encourage you to pause the video here and do this on your own. But is there anything in common with the three pieces? Okay, and hopefully you're noticing that there's a U and a T in all three of them. So if I take that out, UT, if I take that out, what I'm left with in the first term is 7, and then I took one of each of those away, so I'm left with UT plus 21, and I took that U away, so there's no U's there, and I took one T away, so I'm left with 1T. And then for the last term, I took a UT. If I take a UT out of a UT, I can't say that it's just gone. I can't say it's 0 UTs. I actually have to say that there's minus one thing here. Because notice what happens if I were to distribute that. If I were to distribute this back and I didn't have anything to distribute that to there, then the original would just be gone, right? And it wouldn't be the same. So I have to have a 1 when I take something out like this. There's still a 1 left, right? Hopefully you're seeing that. And then if you check yourself, and if you check yourself, you'll never make that mistake, because you'll be like, huh, what happened to this UT? Oh yeah, I need a 1 there, right, to make that work. Okay, now, the second factoring technique, the first one is always to say, is there anything I could take out of all the pieces? If there are, and this is important that you have this down and that you refer to this often, it should become second nature to you, that if there are 4 or more terms, whenever there are 4 or more terms, you can factor by grouping, where we look at two pieces, like binomials independent of each other. So terms have common factors that can be grouped together. There are 2 common factors that are identical or additive inverses of each other. Okay, so notice what happens here. If I have ax plus bx plus ay plus by, okay, there's nothing in common with all 4. But if I break it down and look at these 2 together, and then look at these 2 together, then there is all of a sudden something in common. Okay, so if I do this, there's an x in the first 2 terms. I can pull that out and I'm left with an a plus b. And if I look at the second 2 terms there's a y in both of those. So I can pull a y out and I'm left with a plus b. Okay, so now I have a common factor between these 2 pieces, right? This piece and this piece both have an a plus b in it. So I can pull that a plus b out, and what I'm left with is x plus y, the 2 things that I pulled out. If you were to factor this out, and sorry, not factor it, but FOIL it back, notice what happens. So remember foiling, first, outside, inside, last. If you distribute that back out, what you end up with is, if you do it in alphabetical order, you end up with ax plus bx plus ay plus by, which is our original. Okay, so we're undoing our original when we factor. We're breaking it up into its simplest pieces. Okay, so grouping. Let's take a look at some more grouping. So for 2a, I gave you a hint here. It says you can always factor out a -1 to change signs. That's actually crucial. So if you're ending up with, something where you have 2 negatives and you want it to be positive, you take a -1 out of it and you'll be left with the positive. So step 1 here is since there's 4 pieces, actually the first step before you do anything is there anything in common with all 4 pieces? And the answer to that is no. Other than 1, there's nothing in common. So next what I'm going to do is I'm going to attempt to group them. Okay, so I'm going to group these guys together and these guys together. And in these 2 pieces, I have an n. So if I take an n out, I'm left with r plus 5. Okay, n times r plus 5. And then on my other one here, I want to try to get another r plus 5, but I have this -r and this -5. To get an r plus 5, I have to take a -1 out. If I take a -1 out of that, I'm left with r plus 5. And the key with grouping, you guys, is you always want the things that are inside of these parentheses to match up. so that there's a common factor between them. If they don't match up, then you can't really factor it, so there's nothing really you can do, but you want those to match up. So to get something to match up if the signs are different, just take a -1 out. Okay, so if I take a -1 out, then I have an r plus 5 in that one as well. So I can take the r plus 5 and the r plus 5, right? Take that, since that's in each one of these, okay? Since that's in each one of those green boxes there, I can take that r plus 5 out. And what I'm left with is what's on the outside, n minus 1. Okay, so just combine your like terms there. All right, so that's 2a. 2b, let's factor this one by grouping. So let's just look at this separate. Let's just do this over here. So first of all, I can't take anything out of all 4 pieces. Since I can't, I'm going to group it. So I'm going to group it like this and like this. Okay, if I look at the first grouping there, I know that there's a 3 in common with both 3 and 15, and I know there's a p in common with both terms. And so if I take a 3p out, what I'm left with in the first one is n, and what I'm left with the second one is plus 5. Okay? So 3p times what gives you 3pn? N. 3p times what gives you 15p? 5. Okay, then for the second one, I know that there's a negative in both, so let's take a negative out, and then I know there's a 4 in both. So if I take a -4 out, I'm left with n plus 5. Okay, if you distributed that -4 back, you'd get this original, which is very important that we're not changing the value, right? We're just changing how it looks. So what does this factor to? Well, this guy, n plus 5, comes out of both. That's one factor. And then what I'm left with is 3p minus 4, right? So 3p minus 4 is my other factor. And again, distribute it out, right? So if I take 3p times n, 3p times 5, what I end up with is 3pn plus 15p. And then if I do my other one there, I'll do it in a different color, red. Take -4 times n, -4 times 5, I get -4n minus 20, and that is the same as my original. Therefore, I know that I did this correctly. Okay, 3a. Notice on 3a, we could, since there's 4 terms here, nothing comes out of all of them, we could group them like this. Okay, if you do that, there's a c in both here, so notice what I did. I took a c out, and I'm left with 1 minus 2d. And then on this other one, I took a -4 out, and I'm left with -2d plus 1, which is the same exact thing, just rewritten in a different order. So what I'm left with is c minus 4 and -2d plus 1. The other thing I could have done is I could have taken a -c out of the first term and had -1 plus 2d in both of them. So either way works on this one. Okay, it doesn't matter. It's just the order in which they're written. But don't stress this too much. Either way works with this one. Okay, then I wanted to give you this quiz, but maybe I'll give this to you somewhere in class. So this is everything that we've done in one picture here, you guys. So in one picture, what we've done here is we found the sum of things. When we find the sum of things, we combine like terms, right? Then we write things in standard form, where we start with the order of the highest degree and then rearrange it in descending order. Then the leading coefficient of that would be whatever's the number that is out in front of the leading term, like the highest degree. So this would be -5, right? And then find the product of these things. Once we found the product, we distributed this out multiple times using the foiling type method. Then when we found the product of this guy, it was the same, it was a special product, right, where we had the same thing multiplied by itself in different patterns. This always came out to the first term squared, which is 4c squared. And then since this is minus, it was minus 2 times the 2 terms, so 2 times 2c times 9d. And then plus the last term squared, which is 81d squared. So final answer when we did that was 4c squared minus, what is that, 18 times 2, which is 36d, plus 81d squared. Or you could have just, you know, foiled this out, right? So you'd have 2c times 2c is 4c squared. 2c times negative 9d is negative 18d, and then you do that again, you get negative 36d. Sorry, there's a c missing here, isn't there? There's the c there that's missing. I apologize. 36cd plus 81d squared, right? So anyway, and then we factor the polynomial. This is what we're doing right now. So we've done all of this, you guys. All of that should be familiar to you. Make sure it is for the test. But now we are working on factoring. To factor now, we're asking ourselves to break that thing down. What's in common with both pieces? Well, there's a 3 in common. So since there's a 3 in common, I can take that out, and I'm left with 7b minus 5a. Anyway, I might give you this quiz, so be prepared for it. At some level, I'm going to quiz you on all of the stuff that we've learned, and then we're going to do a test. The last thing here, you guys, is the zero product property. So if the product of two factors is 0, then at least one of those factors must be a 0, right? So basically, once you've factored this thing, what it allows you to do now is it allows you to see where the zeros are. That's places where the graph crosses the axis. Okay, so that's what we're going to get into next time, and we'll do some zero type properties stuff. All right, guys, that's it for this time. We'll catch you guys.